Right. Okay, so we're going to continue with the labs with R, and then we're going to look at the notebooks, the Python notebooks. After that, I think we can finish it up today. So you have the week to turn this in. This is the last lab and the last homework. After we're going to concentrate to work on the projects. So let me go back maybe to the first one. I think we ran most of these, and I started commenting a little bit. I think we get through the functions. Yeah, maybe we start here with the basic types. So basic types that you have in R are the strings that you can either single or double quote. You have integers, floating numbers that you set up like this with a dot, and then Boolean, you need to use the capitals, true and false. Again, the assignment is the left arrow. You want to use that consistently. Whenever you need to write something out, you want to use the paste. So here you can see that when I run this code block here, we have the output that is corresponding to these paste statements. Similar to JavaScript, you can use the comma to separate the strings, and then you will add a space. Vectors can be of different types, as you can see here. You can mix up the notations for the strings with the single and double quotes. It doesn't make any difference. The C stands for column, so this is a column vector, and we can see it printed after we write this. My vector is, and here we can access the element, the first element in the array. The indices in R are starting at 1, sorry. So let me try to, yeah, so if you just print the variable, this is the output that you get. And obviously, if we access the first vector element, then we get just the first element printed here. Nothing special. So packages are giving you access to functionality. So for the package that has to do with ggplot2, we can query what data sets are available that come with the package. And then this is the way to do it. So if I click here, then you see that it opens another window with the list of and the details for those packages. Whenever you want to use a package, you need to load it. So the way to load it is with the library function. So you just call library in the name of the package, and then it becomes available. So as soon as we do that, then we have the data set that comes with ggplot2 here. That is the MPG that we saw a moment ago. That is going to be available, and we can query the data frame. So here we're just assigning it to this df that is a data frame for conveniency. And the add function prints the add. I think you can just use tail also to get the bottom part of the data frame. You see that here these are cars. The manufacturer starts with Audi, I think, and ends up with another German brand here that is Volkswagen. So how do you load data sets that don't come with one of the packages? So you can load them from CSV and other formats. So for the CSV, you would use the read.csv function. If it's another format, JSON, you obviously use the related function. So here we're going essentially to deal with the CSVs because that's the norm. So this one is available in data here. You can see it here, and I think that last time we demonstrated how to see it as a table that you can sort just by clicking it in the files view. Or will want to install some package for this, so you just go along and you'll be able to have a nice way of presenting the data that allows you to filter it and sort it. So here again, we're doing the add of the data frame. So the file gets content gets assigned here to a data frame that is called df, and then here we see what the data frame is about. All right, the data frames are handled by the data.frame object. If you want to get documentation, you do similar to what you do in a Python notebook, where you put the question mark before the function and or library that you're interested in. Here you see the help that appears on the right side here on the help tab. And I think I also mentioned that towards the bottom there are always good examples that shows you how to use the functionality in different ways. Factors are ways to encode information that is appearing as repeated in the data frame. So that typically, if you have categories, then you can set them up as factor. Obviously, this is similar to what we've been doing with D3. When you import in CSV, there is no such information as the data type. So you need to specify it. So here what we're doing is that we're using the as factors functionality to do that. So we're doing it not on a data frame column, but just on a vector here of strings, the alphabetic letter. And so we're going to just print the factors, and you see that they are basically the same vector, but then they have associated these 3 unique labels. Now you see that the vector is in the same order. So there is no sorting that happens there. If you want some sorting, you need to specify it with ordered labels. So if there is a natural argument or ordering in the factors, then you can specify it that way. So some examples, here we're creating an array of letters. This has already run, so I'm just going to go and look at the console. So the 5 letters are here, they're starting, this is an array, right? So we're just slicing it, and it's the array of letters. So not surprisingly, we get the first 5 letters in the alphabet. And here we set it up as a factor, and I think this is the result that we have done here. And here we set it up as a data frame using the factor definition that we have here, and this we will see it here. So you see that we have this variable x that is set to 1, the y that is set to numbers between 1 to 10, and then the factors here that are associated that appear to the right. Again, just coming from the previous operation. Another example. So here we're doing a data frame from a vector of numbers. And it's as simple as just calling data.frame with the number. And this is the vector of numbers. And this is the data frame that appears as a column. A more complicated example with the different types. So here we're setting up the column names. And we're setting up with different data types. And you see here we're printing the columns for the data frame. If you want to see the data frame, obviously we'll do this. Right, so not surprisingly, the columns are named A, B, C, D, E, and the content are whatever is specified by the factors and or just the vectors that are in there. So most of the time you don't do this, but sometimes you need to do some little data manipulation with the data frame. So it's good to know how to do that. So these we already went through them, the head and tail. If you want to list the column names, I think they're where they're listed. I think is this one that is the last two. Yes. The column names is the first printout here for the vectors. So this is the DF, the data frame. So you can check here that these are actually the right column names. And the row names here, if you look into this data frame, they have both column names and row names. Here the row names are the same as the A column as indices. And that's obviously what gets printed out here, okay? So how do you access data frame elements? You can do it with the $sign if you have a string. So here the column C in the previous data frame, you can access it simply by saying df $C. Or you can do it based on index. Again, this index always starts at 1 in R. And you can do composite row column. So you can get just one item in the data frame in this way. You can also, as shown here, use by index. So here we're doing a slice on the columns 1 to 3. So what we get is basically what we see here. Again, the first column here is matching the first column in the F that happens to be A, and the last one is the C. And here we don't specify the rows, so we just say that we want all the rows, right? So that's what we see here. We have the 6 rows that we've seen before in this data frame. So oftentimes what you need for doing reporting and other things in stats, a little bit right. Is that better for, yeah? So what you're interested in is getting descriptive statistics about a data frame. So this is provided by summary function. So I'm going to rerun it again. And the first here console results is what you get. So you see that you get the quartiles that include the mean. And then you get also the max. You don't get the mean value. Don't ask me why, but that's what it is. Oh yeah, actually you get it here. Yeah, I don't know why I didn't put it there. Doesn't seem to make sense to me, but so this is what you would get by calling then the summary function. So oftentimes you use some of these quantities for creating tables. So obviously these are summary tables. So you don't usually set up the table in the notebook, but if it's for doing the analysis, that might be useful. So I've put here the code that does that. And I'm using a library that is for manipulating data frames that is called the dplyr that is here. That has this mutate, group by, summarize, filter functions that you can call. And I've listed here the documentation in case you want to go and look it up. But this basically is code that changes the data frame in a format that makes it appear as a frequency table. And you see the result here. So we're creating, as you can see here, the relative frequency, the cumulative frequency, and here the frequency itself in this table, right? Based on these labels, etc. So here we're basically using the creating a data frame and manipulating it with dplyr to build a frequency table in the form of a data frame. All right, so for each one of these, there are a few exercises. Most of them are easy. The only thing that you need to really pay attention to is the syntax, so that you don't make typos, because that will probably generate errors. So here we want to do create a data frame for the values. Okay, so I don't know how to do this, so I'm going to go and look up in our data frames. And I think there was one example where we do it from a vector. Is this one? So this seems good enough to me. So I'm going to copy and paste. So I'm going to do some of these, and then I'll let you do the rest. So this is the data that we want to put in. So obviously we just need to slap it in there, and this should do it. Okay. Compute the descriptive statistics, summary of df. Okay. We have it here. And then we want to count the number of cases with count df, which is going to give us 2, 4, 6, 8. Whoops. That's it. So we're done with this one. The second one is about loading this, or this is Switzerland. The line is already there, so I guess we just execute it. If we want to look inside, we can just do the F. Here it is. Count the number of cases, count the F, and I think that's about it. We have 123 here. Okay. And then we can move. Yeah, I forgot to mention this. So if you open it and you don't see the menus, it's convenient to pull them out with this button here. Okay, so you can just jump directly to sections, so you make it easy. Now this one is extra easy. Maybe this is the hardest part. So this is to do the frequency table with this. Here it's actually a typo. You see we want to use the Switzerland. So here we have it. Okay, and then we want to go and get the code for the frequency table that is here. So So I'll copy everything because we just in case. Okay, good. So here what we need to do is set it up so that we're going to use this data frame instead of this one, right? Because here we're setting up some value. So I'm going to remove the deployer that we have already. This we can probably just comment it out. The labels will need to adapt, and I think that the list is here. 120, 160. So I'm just going to go and adapt that. Okay. A better way to do this is probably the multi-cursor. If you want, maybe I can show you that instead of doing this hard job here. So where is it? Yeah. So I need to press Option here. And then, oops, if you press Option, then you get the multi-cursor. So we want to put a comma before, a comma after. Then we go back there. We do like this. We put 1. And that looks good. Maybe one just to remove this. Close here. That looks like something that is correct. And then we need to have the breaks that go with it. So the breaks, I'm going to redo the multi-cursor again. So here we did the mistake to remove the previous vector, so we don't know what it is. Data frames, sorry. Frequency table, here we go. Right, so you see that the break here corresponds to the first value. This means included, this means excluded. So we want the first value and then it's 1 plus for these. So we go down, we go back. I think it was exercise 3. So we just need the first value. So I'm going to do this again. So here we want a 1. This we don't need it. Okay. Now I don't know. I think we need the last one too. Yes. Okay. So that looks good. Okay. So now we need to look at the data frame manipulation here, and we need to make sure that we're calling the variables in the same way. So here we were doing cut by value because that's what our data frame was about. And what are the instructions here? We want cholesterol, this variable. So we'll take a look at the data frame just in case, but this probably needs to be cholesterol. The breaks and the labels are set up. Group by value range, this is an inner variable here, so that should work. And the rest are just about computing the different values. So the mutator just adds a column of a given name. And so here we're saying that it needs to be the relative frequency. So it's the frequency divided by the number of rows. Here, the cumulative frequency is the cumulative sum of the relative frequency. So the last two lines, I think, are clear. Here, we want just to make sure that we filter things that are out that are not defined. You see that we have some NAs in here. Yeah, and the previous part is about computing this value range. Yeah, that is the range of the data. So if we just execute this, doesn't work, we get an error parent with mutate current value range, length of breaks and label differ. Okay, so this is because we didn't pay attention. We have either an extra one or we're missing one. So I'm going to go look at the example. I think we need to remove the 401 there. But let me try and go see there. Summary frequency table. Okay, I'm going to copy it down there so we don't need to do this all the time. Oops. Here we go. So here we have 1, 2, 3, 4, 5, and we have 1, 2, 3, 4, 5, 6. Starting with the first one. So there is one extra. 401, okay, and the one extra is from the last one. We have two. We need the last one, so we need to add here 441. Okay, so hopefully that's going to do it. It did it, so we have the table here. Okay. Yeah, I think that's it. All right, so how do you push these exercises? It's explained here. So if you look on top, you have this knit button. So you make sure that everything is executed. So what I would do is that you do the exercise, you make sure that you have the solution to exercise. Then you can come here and do restart R and run all chunks. So you make sure that everything is actually populated. And here we go. It takes a little bit, but you just need to do it once. You see that here it shows that it was modified, so you can save it. And then you go and press this knit button. And things happen, and then this is what you should see. That is HTML. Okay. That is a big, is it HTML? I think it's HTML. So yeah, so that's the big file with all the results in there. So we're not going to publish it, but what we do is that we just add it to the repository. So you can use Git here or do it with the command line, so your choice. So here we've modified the R&D, so you can check it to commit it. You want to add, I think I said it in there. Yeah, add the .md files and also the pictures. So this is HTML that is generated from the Markdown that is here. So you just add this. You can click commit here. Okay, let me just show this. And can I just go back? Okay. Okay. So this is a window that opens on the side, but hopefully you can see it. So the nice thing here is that you see the changes. So for this one, they're side by side, right? So you see that where your work and then you can say what you did. So here we said that we executed this notebook, and we did the exercises. Finished. Okay. And here we're adding MD to repo. So then you just put the commit, and that's it. And then obviously you need to push it to send it back to GitHub Classroom. Yep. So if you want to double check it, I would also do that. You go back to GitHub Classroom and you double check that things appear there. And because it's a markdown, it's going to be rendered as HTML as we saw it in here. Right? It should be exactly the same thing as what you see here, with maybe the caveat that you know, some of the coloring for the code blocks here might differ, because that depends of what GitHub is using and what here is being used. Okay, so okay, I think we're done. If there are no questions on the 0 here, we're going to move to the 1. So the 1 is just very simple. This is about stem and leaf plots. I'm going to resize a little bit this window so we see around. So the easiest function that you can use for doing stem and leaf plots is the stem and leaf plot from base R. So base R is all the things that come with R standard. This stem is the functionality that creates the stem and leaf plots. So here you see a little bit the information about it. So you can see that all you need to do is stem, and you pass X that is a vector. And then you can define a scale. So if the scale is 1, it's going to give you the regular size for the stem and leaf plot. If you put 0.5, it's going to do a stem and leaf plot that is half the size. If you put 2, it's going to do a stem and leaf plot that is twice the size. This has to do with the length of stems of the leaves, maximum that you want, and this is a parameter that I guess you don't need to touch. Is the tolerance on how it defines the splits for doing the stems. Yeah, and as usual, you have some simple examples at the bottom. So you can bet that this is also from base R islands. So if you want to go and run it, you can just go and do that. But I put it here so that you don't have to go and type it. So here we're going to do it with a simple vector and that's an example that is not given there. So we create a column vector with these numbers, and then we just pass it on. So I could do this directly, right? But I've been, I don't know, removing it there, but both would work. And so you have there the result. So this is going to give us some help on the islands data set that you can see here. So it tells you about what the data set comprises, and you see that you have all this. So all these are the land masses basically on Earth, I guess. And here we're just printing their names, so we can see which one they are. Yeah, so the first, so if we just actually we should do this. So we see. Okay, so this is the data set. You see that the item number 1 is going to be the landmass in square miles So some of these are continents, so it's there is a big difference between in square mileage between you know, the smallest island that is in this data set and some of the continents. So it's good to try to use maybe a log scale. So you instead of doing just a stem and leaf plot of the square miles, it's better to maybe compute the log 10. That's what we're doing here. And you see there the results, right? Okay, so how do you do it? Very simple. You just pass in the data set because this is already in the form of a vector, and here it is. So we get this is the one with just using the nominal values, and this is the one that you get with the log 10 of the square mileage. And you see that this is a little bit better in terms of seeing the distribution. This is playing with the scale, and I think I already told you about these two, at least, these three. This is just a quarter of the size. So here we see, we're going to go and see the quarter of the size. It's just two rows that you have here that usually is probably not that informative. The default seems to be the best. So, and here we're not doing the log. So yeah, so we have one peak there. It's not very interesting. Okay, so the exercise is basically the same thing. Use the stem to create a stem and leaf plot of the cholesterol variable for the data in our Cleveland. So the data is here, so we can see it. The cholesterol variable is here. You know that you can access it during $call, and you get also you saw the completion that is here, and this is already a factor, so it's obviously just to turn it into a stem and leaf plot, right? So I'll let you do that. The second part is just to submit your work, same thing as you did before. Make sure that you run all the chunks. You can use the restart R and run all chunks here. And then click the knit to create the MD file and just add that commit, and then you push the whole thing. Yep. If there are no questions, I'll move on. These are really easy. And we get to something that is a bit more interesting, that is the ggplot2. Okay, so the ggplot2 is the package that we've seen in class. That is a grammar, visualization grammar that allows you basically to turn in quickly statistical graphics. So here we're loading the library, so I'm going to execute this. This one, we saw it already. That gives you the help for the packages that come, the data packages that come with the ggplot2 library. And then we're going to turn directly to look at the different types of plots. So here I've put it in the form of just the plots. And so obviously what happens is that each plot is linked to a geometry. So for the scatter plots, the geometry point is what you want to call. So usually people are referring to these as geoms, or geom for the short of it. So we'll do the same. So whenever you use them, you know, if it's the first time, it's good to go and look at the help, because they tell you a little bit what are the options. And you see in particular that there are linked geometries here, the jitter and the count, and then the bin to d. And they tell you when one might be more appropriate than the other, depending on the type of your variable. So there's valuable information here. because depending on your data, you're going to want to use one of the forms. Now, I put this in so you don't have to go and look at those, but that's really the way you want to operate. So you remember the minimal plot with ggplot. You need to define the data and then the aesthetic mappings, that is how the data is mapped to the graphic. So here is where we want to do a 2D plot. So obviously we need to specify an X and a Y. And these are the variables from the data set. Now the AES here is just a shortcut so that when I write this displacement and city here, I don't need to write that it's in this data set. The ggplot will figure it out because I'm putting it inside the AES. Okay? Yes, no, yes? Very good. So here we're setting up, can somebody tell me how this is working here? Is the setup done in the defaults or is it done in the geometry layer? It's written. So here we're doing it in the defaults that are set up with ggplot for the data and the aesthetic mappings. Yeah. And so the only thing that we need to say then is that we want a geometry of point, and because we're not specifying how to realize it or what are the mappings and what is the data, is going to use the defaults that are here, right? So you can also put it in the geometry point, but most of the time it doesn't make sense to do it this way because you might want to add multiple layers of graphics. You want to do, for instance, an histogram and a density plot, one on top of the other. So in that case, you just set it up once and for all in the defaults, and then you just need to add the appropriate geometries, and you're ready to go. So here I'm going to run this one, and you see that it's all good. This does obviously the same. Now here the problem is that we have these dots, but we don't know if there is a dot on top of a dot, right? So if you want to be to deal with the overplotting, what you can do is add some transparency. So here I'm doing it. I'm not doing what I'm preaching. That is that you know, these you would put in the defaults, but that again, I guess that works the same. And what we're doing is that we want to add the transparency. So now the transparency has nothing to do with the mappings, right? And that's why I'm putting here the names. So these are positional arguments, so you can remove the data. That's why it was working before. Again, the mappings, they have to do with how you map the data to the axis and or marks, other marks that you may use, such as color on the dots. But for adding alpha to the point geometry, this is a parameter of the geom point. And you can probably find it in there if you look in the documentation. And so, as expected, this is the result, and you see that that definitely there seems to be some points, actually maybe the majority of them, that have multiple instances of dots, one on top of the other. So these are the two other geometries that were mentioned in the ELF here, the jitter and the count. So we're going to see how they work. So here we're going to see. So the geom, So it tells you that this is a variant of geom point that counts the number of observations at each location, then maps the count to point area. So this is what you get. So basically we're sizing the bubbles. We're sizing bubbles, right? So the point radius gets sized based on the number of observation at each point. And that's another way to deal with overplotting. So some of this is not the same axis. That's why the things are not looking exactly the same. You see that I swapped the axis. But here you see that at this location, where is it? This one here, we have 5 instances, 5 dots. That would be one on top of the other, right? So this is another way to deal with overplotting. Again, it depends of your data, because here we still have some overplotting that is happened because the data are very close one to another. And so you see that the bubbles are one on top of the other, so it's difficult to read. Obviously, you can use the same trick that we did previously with the transparency on this geometry to have both size of bubble plus transparency, and that might do the trick for this particular data set. Another way to deal with overplotting is the geom jitter. This one is just as stated here, adding some noise to the location of each point, and you can configure it obviously if you want, but the default usually is pretty good. And here is what you get here for different classes here for different values, sorry, of the cylinder. I changed again the data that is used here in the plot to demonstrate it, but you can see that this is effective. Still, the points are still too close for me to resolve them in some instances. So I would use some transparency there in addition of this. Okay, the 2D bins count it map is I think it was the last one of the suggested variants of the geom point. And so what you see, what it does is that it creates areas that are binned by the counts of each point, and then they get color coded as you see here in the figure. So I think this is yet another data set. So don't try to compare it with the previous one, but it's obviously very simple to go and change the data set. So here we're doing a little bit of because these I got from the examples for the geom bin 2D. Again, if you want to go and get the example, you just do like this. Sorry, the documentation. We see it here, and I probably copied what was here at the bottom. Yeah, exactly. And here you see that we're setting some limits in X and Y, just to narrow a little bit the range of what is shown in the graphic. Yeah. All right, so those were for the plots that are using the geom point and relatives. And now we're going to look at bar charts. And this is with the geom bar that is here. You see that it has also another related geometry, the geom col. And the long story short here is that there is this variable that is the statistic that is used. So this is a statistical transformation that you want to do on your bars, because usually when you have a data frame, what you want to do with the bar chart is get the frequencies of each one of the categories. And so you need to do a statistical transformation to compute those frequencies. And that's what this geom bar does with a default stat that is set to count. So it's going to count the instances for those, right? So here you see what you get. So the data frame, again, if you, I think you can, maybe you can print just MPG. Yes, we can print the MPG. And you see that here we're doing by manufacturer. So yeah, we saw before that starting with all the, ending up with Volkswagen. Here they're just characters, okay? Yeah, and so here we see the plot that is, how is this ordered? Okay, this so if you resize, then I mean it tries to do the best with the size that you give it. So the default is to have the labels one after the other. They're not slanted, so you can spin them around if you want, but usually when you do some data analysis, you don't bother doing that. Now you see that these are in alphabetical order. So it sees them as factor, but the factors are not ordered. And so there is an ordering that is in there that is either set by the frame or by the default that is alphabetic. Okay. Yeah. So here we go. So, but the compute discounts, my point is that you need to get go in the data frame and count the number of OD cars that you have. That here amounts to something like 18. So you need to create a frequency table basically. And then you can do the bars, and that's what you get here. So the stat that is the default for the geom bar is the count. Okay, so this is very important. Actually, I should write it this way so that it shows a little bit better. Okay, so sometimes you already have the frequency table, and so all you want is just to show the frequencies as bars, right? But in that case, you need to reset the default that otherwise is going to try to compute it again, and you're not going to get what you expect. So you want to say that hold on a moment here, I already have my counts. So don't do any statistical transformation. So you set it to identity. Okay. And so I'm giving you here the example where we already have the numbers. And yeah, this is the line that does it, right? Where we're setting the statistical transformation to identity. And there is a shortcut that is that was explained in the documentation here that I kind of skipped. That is the geom call here that basically is the same as saying geom bar with stat identity. Yeah. Okay, so histogram, it's a bar chart, so you could generate it with the bar chart, but again, you remember that histograms in bar chart, they're a little bit different in that the bars need to touch for the histogram. So you could go and modify with parameters this plot to get your and compute the bins and so on. But ggplot has already all this built in and sorted out for you if you use the geom histogram. So again, we can go and quickly look at the doc for this. And you see that it does visualize the distribution of single continuous variable by dividing the x-axis into bins and counting the number of observations in each bin. So it's actually doing the statistical analysis as needed. And then basically forming the plot with the right aesthetics. The frec poly is the frequency polygon that we've seen also in class. And so I refer you to that. There is no need that we spend more time on this. And this is the example with the histogram. So we see it. and obviously you get what you expect. You'll see that there is a message that comes with it. That is that it picked a default bin size that is here of 30. So you can go and play with this. If you change the bin size, like I do here with 25, we're going to have something that is a little bit different, that is coarser, right, than what you have here. If you want even to go drastic and put 15, then it's going to be even coarser. Yeah. Now that this is useful because really what is it depends of what you're looking at, right? If you're trying to see what are the main modes, then here we have two, and this might be good enough. If you are looking at sub modes, because maybe you think that there are two distributions here, one on top of the other, then it might make sense to go finer than 30. Frequency polygon is you get to just the same thing with lines. And then again, here we see a good example of how you set up the defaults with the ggplot2. And then you can pile up different layers, where one for the histogram, one for the frequency polygon, so you can see both at the same time. Yep. Okay. Actually, I'm curious to know what happens if we switch it around. Your guess is as good as mine. Okay, so that's what we would expect. So you see that the second layer overrides the first layer. And that's probably not what you want to do here, because we want to see the lines on top of the histogram. Otherwise, it's difficult to read. The density plots, you can use the geom density, and it will create a smooth density estimate. Again, you can go and refer to how it's done here in the documentation. Most of the time, what you do is you just use the default. And here you see an example with the MPG dataset and the iWave variable. I think that this is the same example that we had before with the histogram. Obviously, you can put geom density on top of an histogram. Nobody forbids you to do that. Box plot, you're using the geom box plot. So here we're going to take a look at what it is. So in the style of Toki, meaning the way it is displayed, and that's basically the way we described in class last week. You see, you have a tons of options here if you want to change the way the outliers look, the way the box is used. If you want to use notches, it's there. It's just, you just need to turn notch on to true, and you're going to be able to see the notches. And you can also, you see, configure some of the notches properties. There is also the orientation here that by default is going to be vertical, based on what you have. So here I'm turning notch to true, and so we're going to have what you expect. That is for this data set, the box plot with notches. If we put it to false, that is the default, then the notches are gone, and we just see the box plots. Now, if you notice that the default is coherent, because you see that some of these are weird. They're flopping over for the notches, and that has to do with the data. So in this particular cases, the notches really don't make sense. I don't know if there is a way to turn on the notches only for when it makes sense. Maybe there is. But yeah, again, that's why the default is set to false, because in general, you can just assume that this is going to work. The violin plot will always do a good job. Now, here the assumption is that these distributions have one mode. If you have multiple mode, it doesn't mean the mean is not useful, right? And so the quartiles. And so you don't want to use a box plot if you have multiple modes, right? Unless you narrow it down to a unimodal distribution. But the violin plot will work all the time because basically it just shows you is a display of continuous distribution, right? So as long as your distribution is continuous, there you get what you expect. And so here we see an example of that in the same data, right? So you see it's a sum of these, they're multimodal, and that's why the notches failed, right? Because they just don't, they cannot resolve these cases. Okay, this is good. Okay, line charts. So obviously with the geom line, I'm going to put it there. You see that you have different variants. So this is a set of geom paths that is kind of the primitive for the line. You can do geom step. I think I have an example in there. If I didn't, then you can, it's as quick as just swapping it, and you get a stepwise line plot as opposed to the geometry line. So you can go and play with that. And sometimes it's useful. So here it is. So you see, I'm writing this in different lines or same line. It doesn't matter. What is important is that you don't do this, I think. Yeah, exactly. So the plus needs to be at the end of the line if you want to go to the next line. Otherwise, you'll get an error. Okay. This is a simpler example of a line where we're just building up a vector. I'm just going to run it so that you see it, but there is nothing interesting about it. Then the last part here is about second last the Treyu plots. So these are the faceting small multiples. You call them as you like. And all of these. So the reason I'm doing the ggplot2 in detail is not for you to learn ggplot2, but it's for you to learn how to deal with a plotting tool that is using grammar of graphics, so that you understand how to use them in general. And all of those, they have some type of faceting system. So in ggplot, you have the two that is the facet wrap and the facet grid. So they're not part of base R, so you need to call them like this because this is, I mean, yes and no. They're not a geometry. I think geometry they mapped it directly, but here you need to prefix it with ggplot2 so that you can access the right L page. So the facet wrap just wraps around left to right, and then when it gets to the end of the page, it's going to continue back at the beginning of the page, next row. The facet grid creates a grid either by rows or by columns, and that you can specify with the number of rows and number of columns as seen in some of these examples. Okay. So yeah. Yeah, so yeah, you see that you need to use these bars to say what are the variables in the data frame that you need to use. But other than that, I think it's fairly straightforward. You can also use the model notation. I didn't put it here. Please refer to the class that that is this notation. So yeah, y is modeled by x, and this is the y are the y are the, never remember, the columns. No, the rows and the x's are the columns. So look it up in the slides in class. I think I gave several examples on how these notations are equivalent. Okay. Last thing is usually you do this to analyze the data, so you don't want to do very clean graphics, but sometimes you want to polish it so that you have a graphic that is good, say, for publication or for showing somebody else your work. And so there are a number of ways in which you can customize the properties of the graphic. In particular, the setting up axis labels, titles, and so on. So these are some examples. You can find much more in the documentation. I think I put it here. So this is the link that you can go and look at, or you can also access it with the, I think, ggplot2 ; labs ? Before everything, and they should give you the similar help in the form of that you would see in the web page. So I'm going to run this one. Okay. So here we're just again setting up things with a variable, and we set the variables by itself on one line because we want to show it. So this prints a variable in general, but here, because it's a plot, is going to realize the plot. Okay, so that it's not more complicated than that. So here you see that we're setting the labels. So here the size is probably not the right one, and you can customize the size as well, and also here we don't see it, but you can customize the legend, title, and so on. All right, exercise 1, create a scatter plot of the iris dataset. So the iris dataset is already here. So we have it there. So scatter plot, I would just go there and copy and paste. Yeah, maybe I just show you this one, and then we'll do a break, and we'll move on with the rest. The rest of the exercises are basically the same practice with different data sets and same type of plots that you have here. Okay, so here we want iris. We want to map X. So it's always good to print to see the data, so you know how to access it. And here I'm telling you also. So sepal length is the name of the column, and we want to map it to X. So X equals sepal length, and sepal width we want to put it in Y. Then we want to map the color to species. So color equal species. Yep. Okay. Then we want an alpha of 0.5 on the points. And that should do it. Then we can add some jitter and configure the axis. So let's see if this works. Yeah, that looks good. So add some jitter is very simple. We just add the jitter geometry. We need to put a plus here. Otherwise, it's not going to be happy. Okay, that's it. So you scramble things a little bit around, which is good. What else do we want to do? The x-axis label, I think we have this in the customizations. We just need to add these. And we're going to, while we're at that, we'll add the title. Right? So X, we want to just to put this. That is, so if you go and look in the help, you will find metadata that tells you what the x-axis is. That's where I get this information. Oops, sorry. Okay. And this is the title. That was your asked. Okay, here we go. Here it is. Right? So take a look if you have, you see that they're basically similar. They're not more complicated. That this one is playing around with the ordered factors. So you see that here the months variable in this data set has this factor levels that are January, February, March, and these by default are going to be ordered. And if you comment this, then you'll get the default ordering that is going to be alphabetic, right? So I think that's what is asked here. Yeah. Other than that, I think all these are fairly easy to work with. Yeah. Yeah, this is a line chart. Again, very simple. And these are a little bit more complicated, but just because of the data, I think, yeah, once you do the first ones, then you'll know how to do this, but they're all very much similar. And then the last one is with the faceting, and here you see a little bit how to work out the equivalence between the model notation with the Y models X and the vars column rows as needed. Now the wrap, it doesn't care about columns and rows, right? So you need to be in a grid to have the columns and rows. The wrap just wraps around. So you only have really the X part of it. That's why the Y is not set. Yeah. Yeah. So I think they want to get away with this notation because it's a little bit confusing, but that's what it is. Yeah, the exercise 10 is just to do the usual, make sure that everything is running, and then you knit it and push commit. Yeah. All right. So let me go just to have a little bit of water, and then we'll resume with the in 5-10 minutes with the second part that is the R notebooks. All right, so I'm going to get restarted. Share. I think this one. Share. Yeah, okay, good. All right. So to run this, you need to go look in the README, but basically you need to get in the lab and execute Jupyter Lab. I'm using Jupyter Lab. If you want to use something else, you're on your own. The option including just plain Jupyter or the Colab. All right. So we're going to start with the number 3 here. Is the Python basics, and I'm assuming that everybody knows this stuff. So I'll just go and execute everything. If you have questions, let me know. But these I think are just the basics for Python that everybody knows. So I'm just passing through them. This is how you create a data frame with pandas. And you see the examples are the same with R, so you can relate how it's done with R and how it's done with Python. See that here, if you want to accept the column, to access the column named C, then you do a dot instead of a dollar. And then obviously you need to be careful with the counting, where here it's row number 1. In Python we start at 0, if I remember well. Okay, so these are good. Okay, so data sets, you can, same thing, you can have some data sets that are in packages, such as here with Iris. So we're loading this one and we're setting it up into a data frame because it doesn't come as a data frame. And here we go. You can also load in CSV. So this is similar to R. So it's just read CSV. I think you're familiar with this. And you're also familiar with the head and tail function. Here you go. In the notebooks, you can list the files that are around. And obviously, there is no surprise here. Descriptive statistic, you get it with df.describe, where df is the data frame. And you see that it comes in a little bit better format than the R, but I don't know if you can copy and paste this thing. Probably you need to format it in some way if you need to extract these values. The describe will by default work for numerical values. You can tell it to work for categorical variables as well, but you need to set it up as a default. I think you know that. Okay, and this is the equivalent code to do the data tables. No, so not surprisingly, we're just doing more or less the same, but here we're using pandas to create the cuts and add the variables for the relative frequency and the cumulative frequency here. See some of the functions, they have more or less the same name. And so this is our table that is here. Here we go. So first exercise I won't do it because this is very simple. You think you have no problem doing this one. The second one is also straightforward. So the third one is the equivalent of this one. So if you want, is it worse that I do it, or you guys are good with it? I see yes means yes. You want me to do it? No. Okay. Okay, good. But basically the same thing. Okay, so with this said, we can move on with the stem and leaf plot. So there is no stem function per se in R. There is a stem in matplotlib that doesn't do what you expect, but there is a package that you can use that is called stem graphic. So we're going to go and load it. and then import it so that we can use it. Now I was not keen enough to create a code block for this, but you should definitely go and do it. So here it is. So it's a little bit different. You see that they have much more configuration here, but it is not as easy as just saying half the size, twice the size, right? We're going to see how you use it with the examples. So here we're setting it up with a vector of values, and this is the output. So the stem is here, and the leaves are marked with blue. They're here. If you have a data frame, such as here, we're doing just a simple data frame with the same vector. Then the nice thing is that you can pass in the data frame, so you don't have to spread it too much, and obviously you get the same level. To customize the size, you need to play. Did I put it here? Yes. Yeah, with this compact flag here. And so you see that here we're getting it's the same data frame, but we're getting a fraction of the size. The matplotlib stem is here. And if you read through, you'll see that this is a plot. There are a few things that I think we'll go back to when we talk about matplotlib, because there is a dedicated notebook here. You can see here how you can configure the marks and so on. But let's see some example of what this plot is about here. As you can see, this is what the stem in matplotlib does, is a stem and leaf plot, right? That's what we call this in the past. If you want to configure the figure size, this is how you need to do it. And here you get another example. Yeah, so setting up the baseline here at 5. So those are parameters. Now again, the matplotlib is as you're going to see in the next section, is chart typology, types of charts. So you need to go and look at all these parameters to find out which one is the right one for you to use. Yeah, so these are just fairly straightforward application of the code that is above for you to know to use these tools. And I won't go through it unless you have some problem with it. But I think that all the code is there, so you can go quickly through it. Moving on with the matplotlib itself. So whenever you use it, so matplotlib, yeah, I think I explained this already in class. It is the standard that is provided with was provided with Python, and that's what most people have been using, more specifically for doing quality publication level plots. So usually when you want to do a plot, you need to include these two things. You need the NumPy and the pyplot that are defined here. It's customary to use the PLT suffix. So here we're loading this data set. That is the iris data set. Again, the types of plots. So here, can wait. Oh, not good. Okay. Yeah, I need to figure out how you access this. I'm surprised. Did I? Yeah, I did load it. Okay. Oh no. Okay, I didn't load it. Plot in PLT is not defined. Oh, I didn't execute this. Okay. Okay, good. So we know that it's there. Yeah, so mapping, these are what the ggplot calls the aesthetic mappings, but really, because there are different lists here, it doesn't really make sense to think of those in those terms unless you think it's useful for your ed. But it doesn't buy you anything in terms of understanding how the scatter function works. So you actually need to go and look at the help. So now here it is. So this is really the default aesthetics that are created. They were upgraded some years ago. I think that before they defaulted to circles with no fill. So here we are. Okay, bar chart, same thing with bar. So I'll let you go and look at the help if needed. So here we're creating an array and we're doing the bars. So obviously, because this is not a grammar, it doesn't understand statistics, transformation. So you need to do it. That's why we're creating this array already of counts. Yeah. So it just does bars, and you need to say what the counts are for each one of the bars. Which, if you have a data frame, is requires some elbow grease to get going. Box plot. This is a simple box plot, and if you want to make it a little bit more interesting with different variables, then you are basically going to use this in a plot that has multiple variables for each one that you have in your data frame, which is fairly easy to do, but still you need to do it from the ground up. The line chart is here. Yeah, we're using here the plot variable again. Customizations here, you see some ways to set up the axis, the size of the figure, and so on. Yeah, and adding alpha that is set up here. So all these come as parameter of the scatter function. And this is setting the color. I think you can use the longer version. No, you cannot. It needs to be abbreviated. Yeah, it needs to be C. Okay. Okay, exercise. Basically, you just take the scatter plot that is above, and then you do a scatter plot with a different data set. Here is how to do the same with a data frame. Yeah, and here again, the matplotlib will not understand the data frame, so you need to go and get the variable out and just pass it on, and it will do what you expect. So the fact that here we're ordering with the months we're setting up as, so this is the equivalent of the factors, right? In ordered factors in R. So in pandas, there are categories that you can order with the ordered flag. And we pass already an array of ordered labels to use for the categories. So this matplotlib will not do anything with it. You just pass the f.months to it, and then it's going to use it as categories for your bar chart. I guess it's a bar chart here. Yes, it's a bar chart. So it's fairly straightforward. Now on this, I didn't tell you, probably you know it. You can also click here on the left side, and you see the outline. So that's easier to move around. This one is I think this one we saw it already, and the last one is just a line chart with the Tesla data from some years ago. So yeah, nothing specific here. Just you can play around with the options so that you see the string notation there for defining symbols, and in particular the marks. So the dot, I think, does a dot. You can go and look up in the documentation. They have a list of things that you can string that is character string that is linked to a form of a mark that you can use, and so on. Yeah. Do you want me to go over these, or you're good? Yes, no? You're good. Okay. So, okay. So if you think about it, if you want, we can try to do some of this exercise. In the meantime, I'll move on to the pandas, seaborn, and Altair, so that at least we have those done. And if you don't have yet an idea of how complicated they are, if you're into trouble, then we can revise these on Wednesday. So pandas is the library, obviously, that is doing the data frames, and it has functionality that is built with matplotlib to do basic plots. So that's handy if you want just to do a quick plot with your data frame. So we're going to see how this works. So obviously you need to load both panda and oops, sorry, I'm hitting the wrong keys here. Shift, yes, and the matplotlib, the pyplot. So here we're not loading numpy because we're not we don't want to create arrays, otherwise you would do this, but here we're just using the pandas data frames, so there is no need. Using the read CSV for the iris data set that here is loaded of a file. So we could import it with a package. I don't know if it's part of I don't think that there are data sets, or they are, that come with pandas. But if they are in there, you would obviously be able to load them directly and not from file. So here we're doing, you see how it works. We're doing plot.scatter. So we're just using a wrapper around matplotlib. So the parameters are more or less the same, not what you have with matplotlib, and you get pretty much the same type of plot as you would expect with just base R. Sorry, the base matplotlib. The bar is the same. So here we're doing a little bit of data wrangling to compute the counts, and then we can just show the counts. So the counts column is going to have that, right? So if you want to see this, so this is the data frame that we get after we compute the counts, and you see that we have species and counts. So the variable counts we're just using as y, the x is used as x, so nothing more complicated than that. The box plot is here. So this is nice because it by default, you see that it's going to get all the numerical variables and does a box plot of that with default aesthetics. So you don't need to think too much about how to create this plot. It does it for you. When with R, it's quite a bit harder. The histogram, you use df.hist. So again, you can go and look at pandas documentation for that. And you need obviously to say what is the y-axis. So here we're using the sepal length for that. The x-axis you don't need to specify because that's the bins. You don't get any warning, so you need to know that it might be useful to adjust the bin size. But you see that if you just call df east without any parameters, then you get facets with the different continuous variable that you have in your data set, which is quite handy. So it's similar to the box behavior. The line chart here, we're doing some line data, and then you can just use the plot.line with the same parameter that we've seen earlier. And these are some customization to change the figure size. If you want to use a color map here, we're defining a color map for category maps to color. And here we have the mapping. Yeah, so if you want to do color scales, it's a little bit more complicated. So here you see that we're creating one that is a red, yellow, and green color scale. And this is interpolating the colors here, and then we can use them here as a continuous variable for the color. So this is changing the color between these two different values. So you see that as we move from right to left here, we're going from red to yellow to green, right? Based on the variables. Yeah, exercise, basically cut and paste of the code above to different data sets. Here again, the story with the order factors. So the categories that are ordered, so that we get the months to show on the x-axis in the correct order. This one is the same. So all these are just a copycat of the previous, so you can compare how things work in Matplotlib and how they work in Pandas. Seaborn. So Seaborn is kind of the next level, where you have support for the Pandas data frame, and it's 50 already. So yeah, so maybe I'll go quickly for just through this, and then we'll finish on Wednesday, I guess. And then you have some basically the same functionality that you have in Pandas, but it's extended with other types of plots. So this is an example here. The histogram, you can realize it in different ways. So it is the standard with the disk plot, but you can do it in other ways with different functionalities. And the last two here have to do with Altair. So Altair, I think you're familiar with it. So I'll just run it so you see what it is about. Right, so this is the Vega and Vega Lite front end for Python that we've used maybe a month ago. And the nice thing about this is that you can make them interactive. So we're going to see if you go down in the notebook, you can actually set them up so that they're interactive, so you can zoom in the data and so on. And also have tooltips on the data, which is useful for exploring. Yep. So Wednesday, what I suggest you do is that at least you run the notebooks, you look at the examples. If you find some that you have trouble doing, then you let me know, and we can do them together. Yeah. Somebody was saying, by the way, that the Altair, they won't render in GitHub. So that's a known problem. So don't worry about those. But the others, you should see the plots. Yeah. Yeah. The only reason is that it's because it's oh here. So it's, what we could do is save PNG if you really want, and then we can put it in the markdown. But yeah, let's for the moment, yeah, don't worry about it. I'll ask the TAs if that's useful, and otherwise we'll leave it at that. And they'll load the notebook and then just go out and look at the pictures. All right, thank you.